Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 30th, 2025, about 3 days ago. This paper introduces a new model that can generate a 20-second high-definition video clip with synchronized audio in just 45 seconds. The paper is titled Jam Flow, Joint Audio Motion Synthesis with Flow Matching, and it proposes a really clever, unified way to handle both audio and video generation. It presents a single framework that generates facial motion and speech simultaneously, a major step forward for multimodal AI. Alright, so this first figure really lays out the core idea of the Jam Flow framework. On the left, you can see the flexible inputs. The model can take just text, or reference audio, or even reference motion. These are fed into the central component, a novel architecture called a Multi-Modal Diffusion Transformer. This is basically a system that learns to generate different types of data, like motion and audio, together. It has two specialized parts that communicate, ensuring the final output on the right, a series of facial images and their corresponding audio spectrograms, is perfectly synchronized. Building on that framework, this next figure shows a really clever insight the authors had about motion generation. They analyzed an existing model called Live Portrait, which tracks 21 different facial keypoints. These are just specific identifiable points on a face, like the corner of an eye or lip. But what they found, as you can see on the right, is that for just mouth articulation, for talking, you really only need to track 4 key points around the lips. This discovery allows their model to be much more efficient at creating realistic, synchronized lip movements. So, this next diagram really gets into the weeds of how this works. This system uses a multimodal diffusion transformer, which has 2 parallel branches, one for motion, using those 4 key points we just discussed, and another for audio, working with MEL spectrograms, which are basically visual maps of sound. Now, the key is how they are linked. They use something called joint attention, a mechanism that lets the audio and motion branches influence each other to ensure they stay perfectly synchronized. This allows the model to flexibly generate the full output from just partial inputs. Okay, moving to the results. This table compares how the model performs on automated video dubbing against other methods. The key metrics to watch are word error rate, or WER, which counts how many words the generated speech gets wrong, so lower is better, and speaker similarity, or SPKSIM, which measures how well the new voice matches the target speaker, so higher is better. The model gets a really competitive word error rate of 6.39%, and most impressively, it achieves the best speaker similarity score by a wide margin. This really shows the power of its unified audio and motion generation. This table then digs into the raw video generation quality, comparing their model against others for talking head generation. The key metrics are Frichet Inception Distance, or FID, and Frichet Video Distance, or FVD, which measure the realism of the video frames and motion, so lower scores are better. And their model, in its video-to-video mode, gets the best scores by a huge margin. It also scores highest on lip sync error confidence, a measure of how well the mouth movements match the audio, getting very close to the original, real video score. And to really understand what makes this model tick, the authors performed an ablation study, which is where you systematically test different parts of the model to see what's most important. This table shows those results. They tested things like using full versus half of those joint attention blocks, and whether to use a special attention mask to guide how the audio and motion parts interact. The key takeaway is in the last row. The best version uses half the blocks and the mask. This specific combination delivers the best video realism and speaker similarity. So wrapping things up, what all these tests really show is just how important those specific design choices are for getting everything to work together. The big takeaway from this work on Jam Flow is its truly unified approach. It treats facial motion and speech not as separate problems, but as 2 sides of the same coin. By using a clever architecture and an efficient generation method called flow matching, the model creates incredibly synchronized and realistic talking heads, and it does so with impressive speed. Alright, that's all for this AI Research Roundup. Thanks for tuning in.